Okay, 6-7, we are talking about percent of change. Percent of change represents a fraction, and we turn that fraction into a decimal, then that decimal into a percent. So percent of change is equal to the amount of change over wherever you started, also known as the original amount. Okay? This is something that you are going to reference constantly. Yes, Ellen?
So is it the same thing, kind of like part over whole?
Yeah, it kind of is, part over whole. It is. So there definitely is a connection there. I'm going to show you an example. Let's say I want to find and I'm just going to abbreviate, percent of change if I was 60 inches. 60 inches is what? 6 feet? 5 feet. If I was 60 inches to, let's go to 68 inches. Now I think you know the difference, but what's the percentage of change, okay? So, my percent of change, I'm just going to say percent change, is equal to the amount of change. Well, how do you find change? How do you find difference?
You subtract.
You subtract, right? If I want to know the change, I usually subtract. So I would do 68, take away the 60, to find that difference all over the original. What was the original? What did I start at?
60.
60. This turns into 8 over 60. And now this is where I start doing my conversions. In my calculator, I hit 8 divided by 60.
7 point.
No, you must have did 60 divided by 8. 8 over 60. That is 0.133 repeat. And then I turn this into a percent, which is 13.3%. And is that an increase or decrease? Did I get bigger or smaller? Increase. So I say it's a 13.3% increase. That's what we're going to be doing today. This one example encompasses it all. Now, let's think about it here. What I do for percent of change, I find the difference, and then I write the difference. So here's my new fraction. My difference was 8 all over 60. 60 was my original, so original is 60. And then in my calculator, I went 8 top divided by bottom, 8 divided by 60, which gave me this. And then I converted that to a percent by moving 1, 2 over. So that's 13.3%. And then I determined, is it increase or decrease? And it's increase because I got bigger. We're going to do some more examples together. Okay, I made a different equation because I thought, hey, maybe some of us might be confused. So this is another way to think of percent change. We can say percent change is equal to our big number, take away our small number. That's our top, our big minus small. And then on the bottom is where we start. It's our starting number, okay? Let me model through that. If I want to know my percent of change from 12 to 15, I'm going to do my big number first. Which one's bigger, 15 or 12?
15.
Take away my small, all over my start number. What's my starting number? 12, right? Because it says from 12 to 15. So this is our start. It's like when you go from home to school. You start at home, okay? Or from school to home. You're starting at school, going home. Okay, so anyways, this should be 12. What's 15 minus 12?
3.
3 over 12, which is 1/4. Really, you don't, when I'm turning it or translating it, I don't really simplify too much. I just write into my calculator, I write 3 divided by 12, which is 0.25, right? Yep. 3 divided by 12 is 0.25. And then I gotta convert that to a percent. It's a 25%. Now, did I get bigger or smaller? Huh? From 12 to 15, I got bigger. That means increase. So it is a 25% increase. Okay, I want everybody to do this next one on either Doodle Buddy or your whiteboard. All right, we are going from 56 to 63, and I want to determine the percent increase or decrease. So my little equation is I do the big, subtract the small. So what's the big number? 63, take away my small number. Where did I start?
56.
And some of us feel stuck. This is my starting point. This is my finish. My starting point is kind of connected to the word from. From 56 to 63. Okay, so that's where I went from 56, that's where I started, and then I scooted myself to 63. So 63 minus 56 is 7 over 56. And then in my calculator, I go 7 divided by 56 is 0.125. Now I gotta convert that to a percent, 12.5%. Now did I get bigger or smaller? From 56 to 63, is that bigger or smaller?
Oh, it's bigger.
Bigger. Bigger means I increased. Okay?
So are you trying to find out what's bigger than 12 over to 7? Like from...
What's the answer?
Okay, this next example, we want to determine the percent increase or decrease. Some of you are feeling stuck with how do I know if it's an increase or decrease? So I want to just help you understand something. If I go from small to big, it's an increase, and I can determine that right away. So if you don't like to do it, at the end, if all the numbers kind of get all jumbled up and you feel confused, you can right away write increase. You know you're getting bigger. Okay? Now I can do big number, take away the small number, all over to my start. My starting number is 34. That turns into what? 42 over 34? Which when rounded is 1.24. 35, which in the 5 says to scoot that 4. Okay? And now I gotta convert that to a percent. I had 124% increase. Wanna do another one?
Yeah, 32.
I got 1.235.
Okay, going from 65 to 53. Well, right away I know that I'm going from big to small. Am I increasing or decreasing?
Decrease.
So I can just write decrease over here. Okay, because I went from a big number to a small. I'm getting smaller, I'm decreasing. Now I do my big number, take away my small number, all over my starting number. Where did I start? Where did I start, class?
65.
I started here. Your starting point is connected to your front. Okay? So I started at 65. That turns into, what's the numerator?
65.
Wait, what's 65 minus 53?
12.
12. 12 over 65. What does that turn into? So I'm just 0.184. And then I'm going to convert that to 18.4%, and then the decrease just comes down. Okay? All right, I want you to do this. I don't want to do this one.
Wait, can we give it a try?
Please, so much.
Please,
It's talking about gas prices, because you know how gas when they label gas prices, they don't even follow the real rules of math. They're like, hey, it's gonna be $3.14 a gallon. Really? Because we don't do money like that. We only do money to two spots. Why do gas stations decide they want to add that extra spot? I don't know. Anyways, there's a little rant on YouTube. That's great. I want you to find the percent increase or decrease of this price.
Decrease.
Oh, dang it.
My eyes are.
Would be 33, right? Because you got to scoot that 2 spots over. And if it's 0.3, repeat it. Seriously.
Can I go do this one?
Okay, to find this next one, we use this a lot when we are talking about sales or if amounts are going to go up. A lot of times, though, companies use this to describe their sales. All right, so the first thing I'm going to do now is go my big number, take away my small number, all over my starting. My starting price was 45. That is 15 over 45. In my calculator, I'm going 15 divided by 45, which is 0.333, and it keeps repeating, but I just write it to 3 spots, okay? Turn this into a decimal, or I mean a percent, and we get 33.3%. Now is it an increase or decrease?
Decrease.
Decrease, because I went from a bigger number to a smaller number, so I am decreasing. So we can extend this concept to word problems. The following word problem says, I'm going to the store. I found that a pair of jeans I wanted was on sale for $23.99, and the original price was $52.99. What was the percent decrease? So I do my big number minus my small number all over where I started. Well, where did I start? Start is original. Original and start are the same thing. So $52.99. So then I punch into my calculator the $52.99, take away the $23.99 is 29 over $52.99. Now I just go 29 divided by $52.99 and I get 0.547, which is 54.7% decrease. That's a great sale. That's 50% off. You see that all the time in stores. They're dealing with percent increase and decrease. You get 30% or 50%. We are analyzing that.